Here's the part you've all been waiting for. How to turn your antenna tuner into a space heater. All right? For the most part, antenna tuners are highly efficient parts of your antenna system. Keep in mind that there's not much difference between an antenna tuner and a PA tank circuit in your favorite boat anchor. Antenna tuner components are mostly reactive in nature and not resistive. But there are limits, of course. Inductors, in particular, in an antenna tuner are the major culprits when it comes to losses, when tuning vast excursions into the impedance plane. An inductor becomes resistive when the amount of reactance dialed into the roller inductor goes up and the Q of the component goes down, right? So roller inductors don't have a steady Q. They have a high Q when there's very little inductance, but they have a pretty low Q when you dial up a whole pile of inductance. And so our resistance at any time is equal to how much inductance we've got dialed in and the Q at that point. So when the reactance of the inductor and the Q quality go down, or as the inductance goes up and the Q goes down, the resistance in an inductor becomes more of an issue. Where it really becomes an issue is with an antenna system that presents very low resistive values with very high impedance or reactive values. And here we go. So here's my antenna, and this is actually modeled a 40-meter dipole using Simnec, and I'm driving it at 80 meters. And this is what's happening. The resistance or the impedance seen by the inductor is 13.29 ohms with a reactance of 1178 capacitive. And because of that, this inductor is burning 310 watts of power for 1,000 watts going in. So 1,000 watts going in, 310 going up in smoke, 687 going out to your antenna. Let's make this into a pi network. Same values for my antenna, because that's a 40-meter antenna, still driving it at 3.8 megahertz. Now I put a capacitor in shunt, and look at the resistance that my inductor is now looking into. Less than half an ohm, 0.4744 ohms with a reactance of negative 201 capacitive. And lo and behold, we're burning 681 watts. We're losing 681 watts in our inductor with 1,000 watts in. So that'll definitely heat up your shack.